In question 5, we're told that points A and B have coordinates 4, 6 and 12, 2 respectively. The straight line L1 passes through A and B. In part A, we're asked to find an equation for L1 in the form AX plus BY is equal to C, where A, B and C are integers. The question carries 4 marks. For the equation of a straight line, we need two things. We need a point that it goes through, and we've got a choice of two here, A and B, and also a gradient. The gradient is the change in y over the change in x. So writing the gradient, we will have 2 minus 6 over 12 minus 4. You can, of course, swap those over. That will give me now minus 4 over 8, which we can simplify now to minus 1/2. So the gradient is minus 1/2. I'm going to choose A, but of course you can choose B if you like. So I've got this point A, and that's 4, 6. The equation of a straight line is y minus y1 is equal to m, the gradient, x minus x1. At this stage, of course, you can use y is equal to mx plus c. Subbing in, y minus 6 is equal to minus 1/2 multiplied by the quantity x minus 4. Multiplying both sides of the equation by 2, we've got 2y minus 12, expanding the brackets on the right, minus x plus 4. I'm going to add x to both sides, so I've got x plus 2y, and I'm going to add 12 to both sides, and that will give me x plus 2y is equal to 16. So the value of A is going to be 1, the value of B is going to be 2, and the value of C is going to be 16. The straight line L2 passes through the origin and has gradient minus 4. In part B, we need to write down an equation for L2. So here we've got L1, so let's put L1 here, and what we're going to have now is L2. We can simply write that this will be y is equal to minus 4x. If we now have a line that passes through the origin with a gradient of minus 4, we know that's y is equal to minus 4x. Or if you like, you could write this as 4x plus y is equal to 0. We're asked for an equation. It really doesn't matter which form you put in. We're now told the lines L1 and L2 intercept at the point C. In part C, we need to find the exact coordinates of the midpoint of AC. The question carries 5 marks. If we just look at this, we can get some idea of what's going on. You can, of course, do this purely algebraically. What we've got now is a line y is equal to minus 4x. So if we look at that, we're going to have a steep gradient, and that's going to pass through the origin. If we consider now this line, which is L1, if we set y equal to 0, x would be 16. If we now set x equal to 0, y would be equal to 8, which I'm going to put just there. So what we have here, we have the point here 16, 0, and we have the point here 0, 8. So we've got this straight line. Again, this isn't massively accurate, but it'll look something like so. So it's going through these 2 points here. And we're looking for the point of intersection. So this is the point that we're going to have just here. So this diagram wasn't necessary as such, but it might give you some understanding. So what we've got are simultaneous equations. I'm going to use the point just here. If y is equal to minus 4x, what I'm going to say is that now x plus 2y, and that's going to be now 2 lots of minus 4x, will be equal to 16. So what we have here is the following. We have x minus 8x will be equal to 16, and that is going to give us minus 7x is equal to 16, so x will be equal to minus 16 over 7. So that's the x coordinate here, and we can simply go ahead and sub that in to find the y coordinate. If we consider the y coordinate, we can see now that line 2 has the equation of y is equal to minus 4x. So we can say, therefore, y will be equal to minus 4 lots of minus 16 over 7. And that gives us now that y is going to be 64 over 7. So this point right here, this is going to be the point C. So C has the coordinates minus 16 over 7, comma 64 over 7. We also have this point A. Now we're told that A is 4, 6. So if we look at 4, 6, let's go ahead and put that just here. This doesn't have to be massively accurate, but it gives us some idea. So we got 4, 6. All we want now is the midpoint of AC. So we just want the midpoint here, and for the midpoint we add the x's and divide by 2, and add the y's and divide by 2. So what I'm going to have now is minus 16 over 7 plus the 4. And I'm going to write that as 28 over 7, and we're going to divide by 2. Then I'm going to have now 64 over 7, that's the y coordinate, and then I've got now 6, which I'm going to add as 42 over 7, and we divide by 2. So if we look at this right here, we're going to have now a total on here of so we've got minus 16 and 28, which is going to give me 12. 12 over 2 is going to give me now 6. So this will be 6, 7. If I add these two together, I've got 106 in total over 7 divided by 2. That will give me 53 over 7. So that now gives us the coordinates of the midpoint. And these are what we call exact coordinates. So 6 sevenths and 53 sevenths. That's the x coordinate, that's the y coordinate. As stated, you could do this purely algebraically. I've just done a graph now to show roughly what's going on. 5 marks in total.